some highlights. I know, right? So I'm going to be preaching to the choir only. What I will do actually, rather, I will talk a little bit more about what Canonical is doing in Java finally, and then we'll just have a discussion if you have any questions or any suggestions about that. And then if there's nothing, we'll just end up early. No point in just sitting here. Yep, there we go. All right. So this was my agenda. I'm going to talk about OpenJDK for Ubuntu, what we have done in the last 2 years on Ubuntu for OpenJDK. Canonical has been trying for quite some time to get the Java story right. Within this small group, I can tell that I was sort of taken away from IBM just to do that by Canonical. And this is the story of the last 2 years. Open source is the key DNA there. So we have kept everything in that level. It's all OpenJDK original source. We are also doing some extra stuff there, which is again within the OpenJDK projects realms. And then TCK was one of the big ticket items that Canonical wanted to get done. There had been attempts, and it's not an easy thing to do, but that's where AQAvit came in, and it was such a easy adoption for us to use AQAvit and get TCK done. And of course, I'll talk a little bit about OCTLA because that is very important to understand if you want to use TCK. Again, not now anymore. It's not to this audience. All right. So within the last 2 years, starting with Ubuntu 20.04, we now have all the 4 OpenJDK LTS releases available in all Ubuntu LTS releases in service. OpenJDK 8, OpenJDK 11, OpenJDK 17, and 21. Development releases also we do put into our development releases. So Ubuntu 24.10 has OpenJDK 23, and it's a 6-month and 2-year cycle. And please tell our friend George that it matches perfectly. We are so happy, the 2-year cycle. OpenJDK LTS releases are supported on current Ubuntu LTS releases. So 8, 11, 17 are still supported on Ubuntu 18.04 Bionic Beaver for whatever its LTS life cycle. And quarterly OpenJDK security updates are very key, published on all current Ubuntu LTS releases within 2 weeks of them being available in OpenJDK. So that has been the improved story of OpenJDK on Ubuntu, and from pretty much just having OpenJDK 8 and just dumping builds of whatever is the latest release, we now have a structured approach mapping the LTS and non-LTS releases. Then what have we done beyond that? We built on Ubuntu a container technology called Chisel, which takes away parts of dev packages, Ubuntu archive, that are not needed, and lets you build a container image with just the stuff that you need to run your application in production. So if you want to run a Java application, you don't need .NET in your container image of Ubuntu. You don't need Python. You don't need. So all that can be stripped off, chiseled away, and you will get a very thin container image. There was a separate presentation talk on that this morning, so do seek out the recording if you're interested in that. OpenJDK 11 with Bouncy Castle FIPS for Ubuntu Pro users. Ubuntu Pro is our subscription thing for which you can get FIPS compliant OpenJDK 11, and we are using again another open source Bouncy Castle FIPS security provider. We are bringing in Spring Boot Snap package, with apologies to my friend who just talked before me. We still believe that, yeah, Spring Boot is also important equally. So we are bringing in Spring Boot support to Ubuntu as well. And then OpenJDK Crack is an incubation project at the OpenJDK main. It's based on the Linux CRIU technology. So we have worked and got it working with not only Java 17, but also Java 21, and providing that so that you can launch with using the snapshot restore technology, your Java or Spring Boot applications in milliseconds, the fast start time that he was talking about for Quarkus. And then we are working on an OpenSSL-based FIPS security provider, which is basically a pass-through security provider matching or implementing the Java specification for security provider. And it can then be used with OpenSSL crypto, which is what is the FIPS certified crypto on Ubuntu. And we are also working on Maven and Gradle plugins for our Rockcraft, which is our container build system to build container images, OCI compliant container images, where then you can bring your Maven and Gradle projects, combine that with the Chisel technology, and build your final production container images, which are very small, just have what your application needs to run, and are controllable through Rockcraft. So part of our open source commitment was the promise of reliability. And with this reliability, we were quite theoretical, or we wanted to be scientific, and that definition is where we said, okay, how do we say that any package on Ubuntu can be formally claimed as correct? So OpenJDK, the answer was easy. OpenJDK does have a specification, so we just need something to validate that our builds are exactly matching that specification. Now, it's interesting, many times I got asked over the years that if everybody's using the same source code, why would you separately need TCK to certify? Wouldn't it still produce the same binary? But even though you're using the same source code, there are so many platform-specific build configurations, test configurations, so many variations that the things can slightly change. So if you really want 100% confidence, then running JTReg and running TCK are the only two ways to prove that or be that confident that your OpenJDK builds are compatible with the Java specification. This is again not for this audience. So TCK is proprietary software owned by Oracle Inc. But Oracle does grant community access for free on signing the OCTLA. So we are one of the signatories now for the OCTLA, and as a result, we get access to the TCK source. So running the TCK involves accessing the material license under OCTLA, which is test cases, test harnesses, configuration files, and that bootstrapping from scratch is not at all trivial, especially if you are doing it for multiple platforms under multiple configurations. Then you have to define the right test targets, get those compiled, tests compiled, and then configure and run in the test harness. For a distro like ours, where our platform thing is quite broad, we want to fit all of our testing activities in a particular framework at least. We cannot have our functional testing run in a separate way or our regression testing run in a separate way. And so that is why it is also important to have something which is a framework which can be easily repeated across hardware, no matter where you are running it, when you are running it. And that was another key consideration while starting to build our TCK testing. So we were in search of a TCK testing framework that is open source and supported by a community, abstracts the TCK test harness details, presents an easy-to-use interface, and helps us get started quick. And then, not moonshot, but extended ambition was to enable us to build automation of our own. And the most important need was to have a community to seek support from and add to contribute whatever we do as automation. And the answer was AQAvit by Adoptium. We were so involved, luckily the individuals, myself and Pushkar Kulkarni, were involved in Adoptium for quite some time, so we had that confidence. And when the time came, we picked up AQAvit to start setting up our TCK testing. So what is Eclipse AQAvit? advantages. It is very easy to use out of the box. You don't need any specific skills or any deep understanding. It offers a right balance between abstraction and control. That is another key point. Some of the things are abstracted well, but then you don't get control, you just have to use what is provided, and that wouldn't have worked for us. Great developer community, very responsive on Slack kind of instant messaging. I am old school, but mailing lists were never my cup of tea, so Slack was much better. And it encapsulates years of TCK and JDK testing experience by the team that built this. Together, it would be what, 50, 60 years experience, Shelly? Or even more. And that enabled us, having all that ready-made, enabled us to focus on higher layers of automation, and I'll talk a little bit about that as we go through. So we had no specific TCK testing experience on the team. We had exposure to Java and JVM development, but not specific exposure to TCK testing. Canonical signed OCTLA and joined Adoptium in mid-2023. We tried to do a pilot TCK 17 run with a little bit apprehension, but with AQAvit, it took us just a couple of hours to test our one build on one platform. And that's why I said out of the box, it was so easy, so well designed. So that ease of use instilled a lot of confidence in us. Documentation is also very good, which helped us getting started quick. We did face certain challenges because of our infrastructure, but that was another key part, right? We wanted to do it within our infrastructure so that it becomes part of our own testing framework that already exists for rest of the things on the archive. So we started formal TCK runs on our OpenStack VMs with the basic scripting to configure and launch AQAvit. Initially, we decided to focus on just 2 platforms, but for all Ubuntu LTS releases, including that time's upcoming LTS, Ubuntu 24.04. So first, very quickly, we ran into issues caused by the use of local OpenStack instance. There are serious storage limitations within our framework because we were mostly testing smaller packages, or rather packages with much, much smaller test cases, whereas TCK is a huge set of tests. So we began running by one test target at a time, compressing the artifacts every time. And then we ran into the Linux OM killer problem, which would kill TCK while running some compiler targets. So this also was temporarily solved by increasing the swap space on the VMs. But this was going to prevent us from scaling when we decided to do multiple platforms and all the releases that we wanted to do. So this is what was our need, right? Number of Ubuntu versions to test on typically would be 3 LTS and one current development release. So per architecture, we would need 4 VMs for each of those OS versions, 1 VM. And that would put a lot more stress on our test infrastructure than we would want. So then we considered whether if we want to automate this, make it elastic, should we consider containers? AQAvit does provide Docker support to run TCK. We did a pilot run with it that was successful, but we were more comfortable with our own Linux system level containers, LXD. So we decided to go with that. So these gave us certain quick advantages that you could run isolated Linux instances at a system level isolation or constraints. We can run a Ubuntu 20.04 instance on a Ubuntu 24.04 VM. We can run an Ubuntu ARM HF container instance on an Ubuntu ARM 64. So these successes after transitioning this to LXD containers were pretty quick and significant. We needed much less number of VMs. On one VM, we could do all of that platform for all the releases, test for multiple Ubuntu versions. TCK certification could be effortlessly extended to ARM-HF platform, which wouldn't have been possible without LXD. And when these test bugs were discovered, it was easy to reproduce and share the things with the Oracle team to figure out whether it needs an exclusion or it's an issue with our systems. And then it will be even more easier to now build automation around the LXD containers than with the VMs. So there are some custom software infrastructure configurations that are needed. Some test targets need additional services. A VNC server needs to be run, an FTP server needs to be run, a Kerberos server needs to be run for security test. And this again came in handy because we just needed to host these services in a parallel container on the same host and point to that. And again, AQAvit's design had sort of thought about that, where all we needed to do that these services were set up internally, and then AQAvit had a configured path environment variable for all these services to point those to the running, adjacently running containers. So this demo is of how easy it is to run the AQAvit TCK. What happened here? Give me 1 sec. Okay, so I'm going to have to read a script here because it wasn't prepared by me. But basically, this is the steps to first time run TCK, and we just wanted to show how easy it was with AQAvit. Oi, it didn't play. There we go. So it's basically, this is the directory where the TCK material has been cloned. We are making sure we check the Java version and then point Java home to that Java 21 directory. We also have the dependencies to be installed, which are needed to compile TCK stuff. So we run apt update first to get the updated targets on Ubuntu, and then we install the packages. Make, GCC, and contrib are needed. Then we clone AquaTest. This is the AQAvit repo. And then there is a get.sh script. Yeah. 24,000 objects. But from that repo is where comes the TKG, test kit gen. That is the core test harness that brings in the ability to run different kinds of OpenJDK tests. Then we cd into the freshly downloaded TKG. And this is where we will run the TCK from. Now, some AQAvit environment variable configuration need to be set. JCK git, we are going to point it to the local repo where we have downloaded TCK already. And JCK root as well. Test JDK home also should point to the Java that you need to test. So that will point to Java home. and then we need to compile the TCK sources. One key thing, again, because of its proprietary nature, our storage of TCK also has to be access controlled. It cannot be like our rest of the open source stuff. So we do have separate area on our company GitHub where only access control list of 2 people have access to that source. Now, for this demo, we made a custom target for a simple Java math test so that it would finish quickly. And that is what going to be run here. It's just a test target pointed to by an environment variable, JCK runtime custom target, that is java-math. And it's one of the smallest targets. Otherwise, it would take at least an hour to complete any other actual big target. And now once it is run, you need to go to the output directory and all your test results files are there. Did it show the JTR files already? Okay. Yep. So that's how easy it was basically to run TCK against one build on one platform. So we want to attempt extending the TCK certification to Ubuntu on RISC-V v64, RISC-V 64, build a fully automated single-click execution of TCK where iteratively we'll build layers of automation. LXD support is hopefully going to make it easier, and then we also need to make sure we can support test retries. Then another thing, and I believe the AQAvit team also probably has worked on this, but a generic artifact store and dashboarding framework where we can view TCK test history. So I'm hoping that we will be able to contribute to that and or do that effort combined together and have that one as well ready. That's it. That was our way, and thank you so much to Shelley Lambert and her team at Adoptium, but it was my shout-out moment. Yes. Any type of correct. Yeah. Yeah. Perfect. Yeah. Right. Yeah. It's the same framework. Yeah. Excellent. Awesome. That validation. Thank you. All right. Any other questions? Okay. If not, yeah. Yeah. Yes. Good point. Yeah. No. Yeah. Cool. All right. Then it's coffee time. Thank you, folks. Thank you, folks.